Welcome to this final plenary panel on software networks. The idea when talking about this was precisely, and this is a very brief introduction just to set a little bit the ground, is about how relevant software networks are for making the 5G promise a reality. In my experience, and in particular with the 5G PPP, I have not spotted one single project inside the 5G PPP that is not addressing software networks one way or the other. Well, I would say that the software networks are essentially the future, and that though the future is now, because we already now have the software networks technologies and concepts, there are some aspects that, need to evolve, or at least we have to analyze those concepts in the light of the 5G requirements. To help us discussing about this and have a better idea of how we have to make software networks evolve and how we can apply them to realize 5G, we have these our four distinguished speakers. The idea, as we have done in the other panels, is that I would ask them to make a first introductory presentation around 15 minutes or so. When we finish, we all finish the four presentations, we go into an open discussion. I hope that I will not have to make a strong steering of the discussions, because I hope that most of the interactions will come from you sitting there. So please be prepared, take notes, and be prepared to throw your questions to the panelists when we are done. Our first panelist in presenting will be Dr. Xavier Costa. He is with NEC, and he's currently heading the 5G networks R&D activities inside the European labs of NEC. Xavier, when you want. Now, they should change the...
Can you hear me? Okay. So I'm waiting for the slides to pop up. Okay, so the title of the panel is The Role of Software Networks. And basically, I wanted to start with nice ways of discussing. So in my opinion, the role of software networks is to end the traditional telecom business model. So I think if you look at telecom operators, currently they are fighting for survival. We have increasing cost, decreasing profits, and basically SDN NFV is seen as a way to actually reduce CapEx and OpEx costs, and also as a way to enable finding ways for increasing revenues. In this case, the main targets for increasing revenues is basically industry verticals, as well as data monetization. So what we see in this environment is that we have seen more and more OTTs, cloud providers, or startups entering the market. This is what is basically creating some problems in the profits of operators, because first the Google, Facebook started offering services like operators, so Messenger, Facebook, WhatsApp, Skype. So first you offer calls for free, then you offer SMS for free, and this is basically putting a lot of pressure on the profits. Recently we have seen more and more startups that basically, as we move from hardware to software, it's easier, it's lowering the barriers to enter into the market for mobile communication. So we have currently around 3,000, more than 3,000 startups which are funded in the telecom space, which is of course a huge competition. And more you see cloud providers, OTTs also entering into the infrastructure. So you have the Telecom Infra project, the Internet.org, the Google Fiber, the Loon project, Google Fi, and all of this is just basically the OTTs, cloud providers saying, okay, we have bigger and bigger services and we want to have better control of the infrastructure, so we start building our own infrastructure to be less dependent in this space. So at the end of the day, what we see is a traditional telecom business model transformation. One of the things that is very visible nowadays with SDN NFV, it's more and more multi-vendor proof of concepts. So this is basically saying SDN NFV is facilitating having more and more deployments in the future with more and more vendors. Interesting examples coming more from the OTTs is, for example, freemium business models. So suddenly we have Internet.org that is saying, in order to get, in some countries, people to get for a mobile data subscription, we offer some services for free, and hopefully they like them, and then they want to get more. So this started as a small thing. Now there is more than 15 countries which are already offering that through Internet.org, for example. On the OTTs, it has been going for a while with Google, with the Fiber, but now they extend more. Project 5 was basically looking at different operators and trying to have a different offering as an MVNO. And Facebook with Telecom Infra project is basically saying, let's use this SDN NFV efforts to actually bring different operators and vendors together and redefine the way we are having our architectures and our networks. At the end of the day, all these examples are just like from the traditional telecom space, trying to reposition the players and the power of the players. I think the industry verticals, it's a different thing, because so far it was one pie that had to be shared by different players in different ways, so they were competing for this pie. The industry verticals, the nice thing about that, so it's positive, it's that it's making the pie bigger. So as you talk, for example, about automotive, and you have millions and millions of cars all over the world, we are basically talking about having for whoever is owning the users of the cars, a large number of users in addition to what they already had. So these are additional subscriptions, additional revenues. So it's making the pie bigger. In the beginning, you see more and more what it's called connected cars offering. So if you try to buy a new car more and more often, they will offer you again a freemium model where you will get data in your mobile data in your car for free for the first year, and then if you like it, if you get used to that, you basically can continue using that. So here it goes, you have new subscribers for your network. This is now evolving, of course, to having connected platforms for the cars as well, where there is big data, there is a lot of data from the cars, there is a lot of use cases of what you can do with the cars and aggregating information. So this is another, in my opinion, way of increasing the pie, increasing the value-added services that you can offer in your networks. Okay, so we are talking about using SDN NFV for verticals, especially in 5G in the future. And what I thought here was to give a couple of examples of something that has happened already. So this is SDN NFV for verticals on the transportation, and this is already deployed. It's basically a railway company in Japan, which operates about 4,000 kilometers wide train system. And as you know, unfortunately, in Japan, there are many earthquakes. So one of the main upgrades that you need to do in your network is to take care of what happens in the case of disasters. And in one of these upgrades, SDN was chosen as the technology to be used to actually deal with earthquakes in a faster way. So what we are talking here, it's basically 45 traffic control centers, as I said, around 4,000 kilometers wide area. All of these, let's say, probes from the network to make sure that there are no accidents in the trains, that everything is working correct. Has to be, of course, in full sync. Then we have a disaster scenario. One of the control centers cannot be connected to some of the probes. And SDN here, it's very useful to reduce the downtime of these systems such that you don't need to block all the other trains in other areas, redirect the traffic, get as much information as possible from the accident or the disaster that happened, and recover as fast as possible. So this is one example where SDN has already been applied in what we call industry verticals, in this case, transportation. Second example I brought here is education. Since we are in a research environment, I thought probably universities, it's a good example here. This is a smaller project where it's basically a university, Kyoto, which is comprised of 10 faculties, 1 junior college, 10 graduate schools. And what happened here is that as they were doing the planning of how to improve education in the future, how to better integrate all these centers together, they again looked into SDN, NFV. In this case, it was not only SDN like in the previous case, but here they also want to use NFV in the sense of not only dealing with networking, but also with servers, storage software, and try to integrate this together. So what happened here is that all the systems that were kind of scattered per department, per faculty, per college, had to be integrated. So again, using SDN and NFV, trying to have a common infrastructure for all of them, virtualize it, and then have research systems, admin systems, student systems isolated but on the same infrastructure such that all of them could benefit from all the resources. Okay, so these are two examples of how to apply SDN and NFV in what we are calling industry verticals, but this is more fixed wall, right? So this is coming from the fixed side, and what we are trying to discuss here, what we are trying to look at, it's at how to apply this now to 5G. So from NSC's perspective here, you have seen probably these figures a couple of times if you have been in presentations from in the past. What we are saying is we are moving from 4G, 3G, typical more throughput, more capacity evolution to having to deal with, let's say, massive machine type communications kind of scenarios like logistics, energy, or mission critical services like medical care, automotive, transportation, where we have more and more different requirements. The approach here is that probably no company is big enough to be able to cover everything, so we are moving more from just talking with the customers, like the operators, to try to build this more throughput, more capacity systems to actually expand this into the very different domains. So here, the only way to manage that is to discuss with partners. So every industry vertical, any additional service that we need to put into our network slices, it needs to be a collaboration. It cannot be done anymore just on our own. So the approach here is as usual. We just take the 4G, 3G infrastructure. Now we extend it with 5G. We have to virtualize everything with cloudification, so central cloud for normal use cases, edge cloud for whenever we need more lower latency, more processing at the edge, depending on the use cases. Once we have it virtualized, we have our network functions virtualized, our value-added service functions virtualized, and the assets of verticals which become part of the network. And then we start doing what it's called, or it's becoming more and more popular, network slicing. So we can have network slices for logistics management. We can have network slices for personal entertainment, transportation control. So you have seen most of these. Now, as I was showing examples of SDN NFV for fixed networks, now we are talking about mobile networks, and something that I guess most of you are already aware, but I'm just repeating it here for the sake of completeness. In the core side, there has been a lot of investment already, and you can already find virtualized EPC systems in many operators. So this has already happened. This is already COTS hardware, and you can already have a virtualized EPC in a network. Maybe you are already using that. Now from the core, we are moving more to the backhaul and fronthaul. So here is an example of a project where we are involved, which is called 5G crosshaul. What we are trying to do is to take the two domains, the fronthaul domain, which is mainly CPRI, it's very inefficient, it's something that we need to improve. The backhaul side, which might be composed of optical, coaxial, Ethernet, microwave, and we try to to make use of the SDN NFV trend to actually start putting together these domains such that we can be more efficient. So if you have seen presentations about NGFI, about 1904, IEEE, everything is moving towards a packet-based network where we can put different functional splits in the same fronthaul backhaul network. And the idea here is to try to, let's say, have global optimization, global recovery, new services that we can do on top of that. In this project, just to give you a sample, we are following the typical SDN NFV-based control plane approach, where you have a northbound interface to applications, a southbound interface for the data plane, unified services, and here you can see that we try to follow EuCNCV, Open Daylight, ONOS architecture. So it's already making its way into European projects, into POCs. It's happening. Again, an example from this direction, fronthaul backhaul. There has been recently a POC, so a proof of concept of about 12 vendors about how to have a common information model for microwave links on the backhaul, where we can have multiple vendors with a single controller optimizing, doing the resource management of all of them, where you can go through a graphical user interface. And of course, this is happening on the ONF, on the open source environment. Finally, I will just talk, this was fronthaul backhaul. At the end of the day, we want to do network slicing end-to-end. In 5G Norma, this is a project where we are also contributing. We are looking at this network slicing approach of saying, okay, our common infrastructure, the edge cloud and the network cloud, now we want to virtualize it such that we can have multiple tenants, so the industry verticals, the MVNOs, and put all of them into the same infrastructure while allowing them to have different requirements, different service, some differentiation. So here you can have vehicular, tactile, internet access, different vertical network slices, where at the end of the day, what we are looking is at NFV and having different, if you like, composition of the virtualized network functions in order to achieve different requirements. When I talk about this network slicing with some people, they tell me, what's the difference to what we had in the past with network sharing, right? In network sharing, we already can have base stations up to the core networks where you can do slicing in terms of resources, you can do some customization. So what's new? This is just to show we have some building blocks already there, but this is very far from the full picture of network slicing where we want to have this NFV part of the virtualized network functions. So yes, there is some resource sharing, resource slicing that is possible, but there is a long way ahead. So let's slide, Diego. For me, the key takeaways from this SDN NFV trend is basically SDN NFV is transforming the traditional telecom business model. So many different pressures are basically moving our space from the hardware to software, and from having very few players to having multiple players because of the software direction. Software networks are already delivering, so you can already find software networks components in verticals in the mobile network with virtualized EPC, as I said. In the mobile world, this is happening more from mobile core to RAN. So we have seen more specific examples already available in the core. We have quite some advanced components in the front-haul, backhaul direction, and we will see very soon also this in the RAN, so to achieve this end-to-end network slicing. Another impact here is that because we move from hardware to software, it's facilitating having more and more multi-vendor deployment, so there is more and more competition. And this is partially based because open source is, as we move to software, it's playing an increasing role in mobile networks. So that's all from my side.
No, thank you. No, thank you, Xavi. Our next panelist should be Georgios Skelas. How do you pronounce this? Skelas, but he was not able to come because of a customer engagement meeting last time. So Vasilis Frederikos, it is that the way, right? Is substituted. Vasilis has been, he's with Nokia as Georgios, and he has been looking at his CV. He has been very much active all over Europe, teaching in several universities, and dealing with some issues with autonomic home networking. That this makes an interesting case here. Please, Vasilis.
Okay, so thank you, Diego, for organizing this panel, this very interesting panel. As Diego said, I'm substituting for a colleague who couldn't make it to come today. And I'm saying this again just as a proof that in Nokia, apart from working on providing software as a service, network as a service, we also have expertise as a service nowadays. So, as you see here in the first slide, Nokia's vision is that 5G is a key enabler to the fully programmable world. But looking at this title, I can take it the other way around as well, thus answering one of the questions of this panel. Programmable world, software networks are a key enabler as well for this 5G that we are all talking about. So we will see in details in how many ways this is true. Sorry. Okay. So let's start by pointing out what is the main difference between 4G and 5G networks. If I would like to spot the biggest difference, I think this one is the diversity of use cases that the 5G networks need to cover and support efficiently. So 4G historically was mostly focused on providing mobile broadband, but of course 5G will extend this. We will go further in providing more and more bandwidth, but 5G is not only about this. 5G is also about critical communications support. We see here we will have the tactile internet, for instance, use case with very low latency support, and use cases that need ultra reliability. Apart from this, 5G will be also about massive machine communication, we will see the number of devices increase by a factor of 10 to 100. Of course, we need to have machine-to-machine communication, ultra low cost, and we will have billions of sensors and machines with energy consumption concerns, and of course, which need to provide a long battery life cycle. And to complete these use cases, I would add as well an example coming from the 3GPP standardization body, which is about network operations, covering mostly the part of slicing. You must have heard a lot of slicing in this conference, and also the example of a vehicle to any communications. So, of course, Nokia is currently very active in all these aspects of the 5G with real-life scenarios. We have showcased massive machine-type communication, critical connectivity to enhance automotive communications, and also some 10 gigabit per second massive broadband scenarios. So, of course, to achieve all these requirements for 5G, starting from higher data rates, ultra-low latency, robustness, connectivity from any to any device, any to any infrastructure, let's say, we expect to have too many technologies which are able to achieve this. The big challenge with 5G is how to gather together all these technologies in order for them to work in a seamless way, in a way which is not, let's say, contradictory. Because probably bringing in the world some of these techniques can be achieved in a more easy way, let's say, but having an umbrella that covers all these diverse use cases in a seamless way and in an invisible way from the user's perspective is not that obvious. So this is the big challenge, one of the big challenges for 5G. Of course, these new technologies will have to do with air interfaces, for instance, millimeter wave and massive MIMO, but they will have to do as well with the core network. Here we can mention the network function virtualization, software-defined networking, slicing as well, and so on. So when it comes to the operators, from an operator's perspective, this is very important to be able to provide all these functionalities as software as a service. So being able to tailor the needs of each service out of small pieces. So here in this slide we can see some use cases, 5 use cases that we think will be important for enabling 5G. Of course, the first one is network slicing. We have mobility on demand, dynamic experience management, service-determined connectivity, and fast traffic forwarding. Of course, this will be always part of the game. I will explain in the next slides what each one of these use cases is about. So, of course, network slicing. So this is mostly how to optimize service delivery for heterogeneous use cases. One approach to 5G is to make it in a way that we can offer it as network as a service. So if all the elements of a network, starting from access to core, the OSS, the security, the analytics we have are virtualized, then we can have tailored solutions for a service out of slices, coming out of these slices. And this is very important. Imagine you have an enterprise solution which is tailored in a vertical way in an X as a service manner. imagine solutions for logistics, for automotive, for healthcare, for other utilities that can be tailored out of these slices. So the enablers for this slicing in 5G, the enabler technologies, of course, will be, again, the NFV and the SDN. Coming back to the question, of course, about the necessity of software networks. Just to mention here that as Nokia, of course, we participate in many activities around this topic. We are the leader of 5G PPP Norma around multi-service architecture design. We have our own 5G ready platform, which is called Airframe. And of course, we are working actively in the programmable core and transport networks. So the second one of the use cases I mentioned earlier is dynamic experience management. So if the name is not really speaking by itself, I would say is about how to improve the quality of experience in a 5G network. And of course, we all know that, techniques like quality of service management are not enough and are not really tightly correlated with the quality that the user experiences. And so we need to find more efficient ways, and mostly for a network like 5G, which will be that complex in terms of supporting all these devices, all these protocols, all these infrastructure we have. It is very important to find the ways to go in depth into and in an intelligent manner into all the tools we have, starting from KPIs, logs, other data that we gather from the network, in order to be able first to predict and of course to be able to resolve any kind of situations in a more efficient way. So of course here we have this famous loop coming out, I think, from autonomic computing, sensing the operational state of the network, analyze, of course, in a smart way, decide about the future actions to force in the network, and of course acting in a way back in order to resolve situations. This improved quality of experience process will be able, of course, to increase by a factor of 4 compared to today the QoE. We expect to have like 100% more successful sessions whenever congestion arises, and of course 20 to 30% more capacity just because of a better resource utilization. So, next use case, service-determined connectivity. And of course, this is mostly because around latency, resilience, and of course the fixed to mobile convergence. And it has to do as well with any-to-any type of connectivity. In fact, ideally, a 5G access point, we expect it to be able to route the traffic either to a centralized IP anchor or a local IP anchor, or directly to the mobile edge computing device, according to the service or the application needs. This would be the ideal use case. Currently, with LTE, we do not have this possibility. LTE, in fact, does not support relocation of the IP anchor point. And this is this is a hard constraint, let's say, for 5G. Of course, in LTE, we have what we call LIPA, the local IP access. We have as well the SIP TO, which supports traffic offloading, but these do not support dynamic and per case relocation of the IP anchor points. Yes, of course. Okay, thank you. So, the next use case, which is very one of the main pillars of 5G, is fast traffic forwarding. We mentioned earlier the need for ultra-low latency communication, and the key point here is what we can do in order to allow for switching in lower distances from the devices, the end devices. And here we can see all the possible paradigms that are foreseen for 5G. We can have native device-to-device communication. The typical latency for such a communication would be around 1 millisecond. We can have the switching at the radio access point. This would lead to a latency of around 2.5 milliseconds. If this is not possible, we can have a switching point at the aggregation of somehow an aggregate cloud. This would lead to a 10 millisecond solution. And of course, if none of this is possible, then we will have to go to the core network, leading, of course, to much higher latencies, more than 50 milliseconds. Again, Nokia is quite active in these aspects. We have a vehicle-to-infra trial and demos on German motorways. We are pioneers in mobile edge computing. And of course, we participate. We are the chair in ETSI ISG group. The last one of the use cases I showed earlier is mobility on demand. Very quickly here, I would say that we already know that only 30% of the users attached to cellular networks are really mobile. So imagine all the overhead we introduce to the network by supporting mobility for all the rest of 70% of the users. The idea here is that we could have some kind of mobility support only for users that actually need to have it. So a default operation, let's say, with mobility switched off and then enabling it on demand. And to conclude, as Nokia, we are active in shaping and aligning the global 5G end-to-end ecosystem. Of course, we cannot be all alone in this race. We have strong collaboration with research institutes, academia, regulatory and standards like 3GPP, ITU, and of course, policy-making organizations. That's all. Thank you very much.
Thanks, Vasilis. Our next panelist is Paul Veitch, who after a trip forth and back to VT is now leading a group that is precisely doing characterization of ENFs in the VT labs. No, it's maybe it's the other one. Sorry, maybe no. Probably I made a mistake in numbering the.
No worries.
And so since there have been a couple of comments from Xavi and Vasilis on what the operators need, etc., and he's coming from an operator, I hope you will bring some points to counteract what this is.
Thanks, Diego. Yeah, my name's Paul Veitch. I'm based at BT Labs in the UK. I work as part of a small team who've been driving NFV for the past 4.5 years, both driving NFV within BT and externally to industry. So I'm going to actually try and address, there were 5 questions, 5 exam questions, and they're quite tough questions. I'm going to try and address them, provide views and reflections on those from the perspective of a carrier service provider who's been on a very interesting NFV journey over the past 4 or 5 years. The first question I would paraphrase as does 5G need NFV and SDN? Okay, paraphrase it to make it simple. What we have to do there is reflect on what NFV and SDN offer. So the two key facets of NFV and SDN, cost optimization and service agility. Okay, so the logical answer could be you could build 5G without NFV and SDN, but the penalty will be higher cost and reduced flexibility. For that reason, we should strive and endeavour to leverage NFV and SDN as much as possible. That said, I don't think we should be overly prescriptive about what we do where and which parts of the network. Couple of examples where NFV and SDN, or NFV in particular, may not be the appropriate thing in particular component parts of the end-to-end infrastructure. So perhaps in the RAN space, for example, where there are complex and process-intensive functions, but also some of the use cases that people have talked about for 5G have involved critical infrastructure, supporting critical services. Some of them are listed here. Just raising a little kind of warning flag, we need to be mindful of the maturity of things like NFV. Okay, yeah, we've been working on it for 4 or 5 years, but in terms of real-world, large-scale implementations, we're maybe not quite there yet. The next question was to do with slicing, and slicing has been talked about a fair bit. There was a good panel session yesterday where people were getting into good discussions about slicing. I don't want to repeat too much of what's already been said. I just had a reflection on how different is slicing to things like IPVPNs. I come from a fixed network background, so I like talking about IPVPN. So we think, what are properties, key properties of IPVPNs? Well, we logically separate and isolate customer traffic on a shared infrastructure, whether that's an MPLS VPN or based on the internet. And then we think of 5G, and everyone talks about multi-tenancy and slices to isolate and separate services on a common infrastructure. In the fixed world, we provide multiple access types to the VPN, fixed access, DSL, Ethernet, leased line. In the 5G world, we hear a lot about there'll be a diverse range of user handsets, IoT sensors, connected cars. And then the third kind of facet of IPVPN to compare then with 5G, we use quality of service functionality, usually as a means to prioritize traffic within a VPN. So we prioritize the business critical stuff over the best efforts. And achieving quality of service for a range of service types on 5G, potentially with slicing, is going to be one of the key aspects. What is a slice? I don't think we should get in, well, we might get into that debate again, but there was a lot about it yesterday. But from my perspective, I see it as, well, you define the slices perhaps by the granularity, in other words, how thick or thin the slice might be. So you could range from a per customer end-to-end service function chain through to slicing where you're separating mobile operator traffic, and you can have things in between those two. I think it's somewhat more interesting to talk about the challenges of slicing. One of the first key challenges, you have to achieve resource management and almost like guarantees for some services over others, and you have to do that on an end-to-end basis. And someone yesterday pointed out, you then have your fixed networks and your radio network and radio resources to be stitched together end-to-end with the core. So that's definitely a challenge. The second challenge, I just point out, maybe again coming from a telco background, networks are built using layering, and we often abstract technical details in layers to provide services to layers above to be consumed. We do that for good kind of technical and scalability reasons. There's also commercial and regulatory reasons why we have these layers and the boundaries between them. So yesterday I was hearing people talking about there's a vertical and the horizontal, and when you start slicing vertically, you maybe get into some considerations about exposing aspects of your layers, okay? Oh, I meant to hit that earlier, but never mind. Question 3, again, I'm going to paraphrase because it's quite a long question. What are the gaps of NFV and SDN that should be addressed in the context of 5G? Well, there's no point talking about gaps until you know what your target is, okay? So, you know, just putting it very simply, successful 5G implementations, there's going to be high performance at unprecedented scale, a very high degree of automation, dynamic service provision, programmability, and it will also need, if it's going to function properly, it will need deep analytics insights, performance awareness, and the tooling to support all that will be quite key. So in some ways, that's then the bullets underneath kind of address those points and say, well, some of the gaps with NFV, you know, how do we achieve guaranteed network performance? You can have the vanilla flavor of standard x86 servers, or you can start getting into a lot of fine-tuning. That fine-tuning you do to achieve performance that you want, whether that be throughput and latency, but also the resilience and reliability is going to be absolutely paramount. High degree of automation and control. You're now maybe talking about life cycle management, the life cycle management of your physical functions, your virtual functions, and now how these are stitched together to make slices. And essentially what I would say is we need the combination of all these things. We need clever orchestration and management that isn't just able to bring up a new service, but it's able to manage that service in life and use statistics and data from the network to manage that capability on an ongoing basis. Okay, just making sure don't run too far in time. There was a question about open source. Just give some views on open source. The slide's got some examples of open source projects that are relevant to NFV and SDN. I think in the last couple of days I've learned about another 4 or 5 that I actually wasn't aware of. So there's a lot of open source kicking around. In terms of what the question asked, Linux is an example. Linux is open source, and you could say it reduces the diversity of the ecosystem because there's a heck of a lot of Linux there, but I would argue that that's promoted rather than inhibited innovation. Just to give a quick carrier perspective on open source per se, you know, we build networks which are very complex networks, complex system stacks. Where does open source fit in all that? Well, you know, it has a role to play. Sometimes it's within systems and capabilities that we may self-build, or we may purchase off-the-shelf capabilities from vendors, and sometimes the vendors will actually make use of open source components to help with the interop side of things. Going completely to all open source, I would say carries huge risks. A network operator's got to guarantee the network for its customers, okay? We have to think of risk in everything we do. So the question there is, when we talk to a vendor that we've bought a product from, we can sit in a room with a vendor and talk about the roadmap and what features and functions come when. In the open source world, yeah, there's roadmaps, but the process for driving something that you need into that process is less clear. So I would just say a couple of key points about some of these open source projects in relation to NFV and SDN and beyond NFV and SDN. I think they need to be really clear about what their objectives are and what their objectives are in relation to other similar projects. The last question, which I think was definitely the hardest to answer, because I don't think there's an easy answer. It's not that kind of question. So I'll just come up with some ideas around it. So it's kind of the relationship between NFV and SDN and the 5G architecture. Taking NFV as an example, well, the first thing I'd say, probably should try and view NFV and SDN as a parallel thing, an enabler, a tool that can be used to implement 5G architecture. But the implementation choices should be, there should be a degree of freedom there. I don't think we should over-prescribe some of this stuff. You know, we put a firewall in at a peering point between our fixed network and the internet. Doesn't matter if that firewall is a VNF or a physical function on proprietary hardware. Well, probably very good reasons to virtualize it, but again, I'm not sure we should be prescribing that. Where I think NFV and SDN, you can think about the relationship between it and the architecture of 5G, especially in the core. You can start to think about moving from small numbers of highly densely aggregated core nodes, points of presence, to more distributed architectures. What's the argument for doing that? Well, highly loaded nodes you might not want to implement using commodity servers, whereas if the traffic loading is somewhat lower because you have a distributed architecture, that might make more sense. And the same argument could go for resiliency and reliability. When you have a small number of big nodes and one of those nodes goes down, you're taking out tens of thousands, hundreds of thousands of customers simultaneously. And it's obviously got a role to play in the way we provision and manage services. I think the last point I've got on that slide is really just saying we never build new networks and throw away the old ones. The old ones coexist for quite a long time. Previous generation networks to this have been built without NFV or SDN. So, you know, we will be interworking with networks that don't use this enabling technology. So, yeah, that's all I was going to say. That's the last slide.
Thanks, Rob. So, the last panelist to make a statement is Carlos Bernardos, who I would define as our ITF man. He's extremely active in the ITF, apart from being a professor at the University Carlos III of Madrid, and the technical manager of the 5GX project, that is 5G PPP project that is precisely considering multi-domain and multi-technology environments.
So thanks very much, Diego, for inviting me to the panel and for the guiding introduction. So I come from academia, so I may be following a bit different approach from the previous panelists, although I'm going to also follow the same approach of trying to ask the very nice and challenging questions that Diego posed to the panelists. One thing is that I didn't know how to start with the presentation, so I was trying to find something that could summarize a bit, but in a funny way, the main focus of the panel. And well, nowadays we use and we have virtualization, softwareization everywhere. So basically, that kind of reflects that. Actually, that could have been perfectly a meeting preparation for a proposal of a new project 2-3 years ago. Like everybody is virtualizing, softwareizing everything. So then let's try to go into the questions. So those are the questions that are basically driving the panel, and I will try to go one by one. It's actually, I mean, I was nicely, I don't know if surprised, but it was nice to see that I think in some of these questions, I'm going to be very much in agreement with my previous colleague. So let's go one by one. So first one, requirements of 5G and the role of software networks. So how software networks may help in this and how 5G could be done without the use of software networks. So those are the very famous things that 5G networks should be providing. That's the list. And in my opinion, I think that the first one or the main one where software networks may help is in flexibility. So basically for me, softwareization in networking, it's adding flexibility. Many people argue that it's also about cost. I personally believe that cost is an issue, but I don't see that major difference there, but in flexibility. So I think that in reducing the average time to create, to deploy, to adapt a service, that's where software networks really help. And this is something, for example, where 5GX project that I'm working is actually focusing on this kind of agility in providing the service. Another thing that I think is, it may help, but it's also very challenging, so something that very much for the future is in trying to create a more reliable internet. So I think software's, the fact that it's being in software and you can change, you can react, you are much more flexible, it may help to improve the reliability of future networks. Although this is one of the main weaknesses, also in my opinion, of current technologies in terms of SDN and FV. This reliability, robustness, there is a huge room for improvement there. But I think that if we manage to work there, that will help a lot in future networks. Another one that I see, just to highlight three, is saving energy. I think that the whole softwareization thing may help in this. Again, because we concentrate resources, it's easier to save energy in that case, and also because of the flexibility, we can just turn on off things, also helping into reducing the energy. So those are the three main requirements where I think that without software networking, it may be possible to achieve them, but it will be much harder, as we also discussed in the previous presentation. Second question, slicing. Another term that is in almost any meeting in this environment, we talk about slicing. It's about the slides and slides, like this one. So it's everything about that. So many different definitions of a slice. So I'm going to just go through one of them, because, I mean, you can consider a slice depending on if you slice services or you slice resources, which kind of resources you are slicing. Is about only networking, it's about network and compute and storage. So there is a huge discussion that you can have on that. So for me, personal opinion, and also having this very much focus resource view, for me a slice is a set of virtualized network resources, so virtualized resources that are booked for the use of one single consumer, let's call it tenant, whatever we want. And by the use of the word use, I mean that consumer is capable of using those resources as if they weren't its own. And that's meaning not only using, but configuring, managing the life cycle, managing everything, scaling all those resources. Of course, that also implies that there should be isolation and performance guarantees according to a given contract, because otherwise that will not be usable in a real networking environment. So that's, for me, my definition of a slice. I guess many people will disagree because there are many different understandings of what a slice is. Then, third question, which are the evolution of SDN and FV technologies. So, okay, we are kind of assuming that SDN and FV will be there. Xavi presented some examples showing that this is already here. But if we want to really go into using this in the future, what are the things that we are kind of missing or we are not very good at that yet? Again, personal opinion. So just to mention some of them, if we focus on NFV, I think reliability and robustness is key there. Software, if used properly, can help a lot in that. But again, this is a new environment, or this use of software in this environment is kind of new, and there are many things that we need to really go into the architecture, how we use software in order to really provide robustness and reliability. And there's also the reliability of the software itself. So there are many things that there's room for improvement. Isolation, there is performance isolation, but in general isolation, this is critical. Unless we really ensure isolation, many vendors will not really go into that because there are many issues related to isolation. So this is something that we really need to guarantee and still not yet completely done. Security is always an issue. Again, this is similar to reliability and robustness. The use of software, if properly done, can enhance a lot security. But if poorly done, as we used to do in other environments, like applications that are not basically dealing with the network service, security will be maybe a huge gap there. So there is something that we need to work into how to make use of the software characteristics to improve the security. And of course, integration with legacy networks. Then in terms of SDN, again, reliability and scalability is very much an issue there. Scalability especially, we need to go into different architectures that ensure that decentralization that provides a lot of gains doesn't come with a cost that you have to pay. And then the northbound API. So SDN, there are many SDN approaches, many SDN controllers, but then what is the API that we have to control or to use those controllers? There are efforts going on there, but it's critical to kind of achieve some kind of standardization there in order to make all those tools usable at the end. Question 4, about the open source macro projects. So I also tend to agree that this will foster innovation. I don't see that as something slow in innovation. I really see that open source will help a lot into getting new ideas, new stuff going on. But there is also a cost associated with that. That is, as was also mentioned, the lack of control, kind of, because there is no governance model there. There are many different projects doing their own stuff. There is no coordination. And we may have also the risk of ending up with a platform, software platform lock-in. So we go into one of these projects, we put our effort there, and this is not really compatible with the others are doing. So that's also a potential issue. And that's why I think that it's critical to try to make the links between standardization and open source much more tighter than they are today. Basically, many people, there are some opinions that say that open source projects can do things faster than standardization, and that's true. But there is also the good thing of standardization is that you have the guarantees that you have interoperability. And with that, we just go for open source without the backing up of the standardization or the kind of the guidance, that may be a risk. So there's something, also personal opinion on this. And the last question, how do I see the application of software networks affecting the future of 5G architecture? Well, first, disclaimer is I think that software networks is there. It's kind of we can call it an assumption or a very well adopted pillar for the 5G design. So that will be there for sure. And we can see that in all the projects and also in all the products by companies that software networks is a pillar there. But if we really embrace software networks, we also need a kind of a change of mindset. Because doing things with softwareization, virtualization is just not like in the first picture, okay, let's virtualize this entity and move it to the cloud or move it to a data center. I mean, with software, we can do much more. So let's try to also change the mindset. Let's say, okay, we can design things in software, how the functionality should be programmed in the software, how the network should behave if we think of the network as an OS instead of a set of distributed entities performing some functionality in order to forward packets. Let's see on how NFV and SDN can complement to each other. They are technologies that offer independently quite a lot of features. They interact for some aspects, but if we really look into how they can merge and can complement the game, the overall game will be much higher. So those are the things that I believe we need to look into software networks in order to really enhance the 5G architecture in the future. And with that, I try to be on the 10-minute slot.
10 minutes exactly. Thank you, Carlos. Now that we're done with the introductory talks, I would really appreciate that you help me in saving my time and and doing my work precisely interacting with our panelists. So from now on, I expect a forest of raised hands, willing to ask, make comments, etc. Who dares to be the first one? Okay, good. Good. I guess that's, wait 1 second.
So I hope that the question is clear. The first question of the panel was about how virtualization help development of 5G. So I have the opposite question. Do you think that there are some aspects in which virtualization can be a problem in developing 5G? For example, I have this the example of computing. Virtualization was an old technology, and all the virtualization software was very, very slow. At a certain point, when virtualization became important, they put something in the CPU, and now virtualization go very, very fast. So someone discovered that to virtualize the CPU, you need to go inside the hardware changing something. So the question is, do you think that also in 5G, there are some particular aspect in which virtualization can be a bottleneck, can be a problem? I don't know, for latency or for reliability of whatever. So.
Just don't look at me. Just go for. I expect it to be as much as dynamic as, please.
Question to be. I think the answer is possibly. It depends on which aspect of the 5G architecture you're talking about, whether you're talking about the access, the RAN, or the back end, the evolved core. One of the points I was trying to say was, don't over-prescribe the use of NFV or SDN. If you start fine-tuning and adding special hardware back into a commoditized server, you're diluting some of the benefits of doing it in the first place. And you start to say, is that still NFV? If you your starting point's a commodity server that you then fine-tune and add bespoke pieces of hardware or NIC interfaces, is it still NFV? So there starts to become, I think, a grey area between completely pure proprietary hardware from vendors, the off-the-shelf stuff we can buy and work without doing too much fine-tuning, and then something in between the two. Whether that's a problem, you say, is it a problem? I just think you have to think where it's appropriate to do, either use NFV or not use NFV, but not over-prescribe that you must use it, would be my opinion.
Just some additional comment from my side. In my view, we are not doing virtualization for the sake of fun. Virtualization is happening because, as I was saying, telecom operators want to reduce CapEx and OpEx. And virtualization is seen as a way of moving from hardware upgrades to software upgrades. So it's about money. The price is clear. Specialized systems, high-performing systems, non-virtualized will be higher performing, but they will be more expensive. The trend is going into cheaper systems.
Or do you have, no, you say that you have anything else? Well, but let's give some other opportunity to, no, much better. Oh, yes, sorry, Manos. The light is really blinding. Sorry.
We forgot our sunglasses.
So for the next.
The question from my side will be about what has been discussed a lot in this conference about slicing. Okay, so my question is, I would like your estimate on whether you foresee that the slicing concept and definition will be something that will be agreed upon the community, so we have a sort of standard definition and a standard API so that people can actually understand what the slice is as a value proposition, that they compare slices among different providers, vendors, whatever, that they can combine them to build services, that different slices will be actually interoperable, or if there are efforts that are going on the standardization towards this front, or if you foresee that we will have a situation similar to what was shown in one of the presentations with Linux, with several different flavors of slices that might look a bit alike, but they are not fully compatible. And what the implication will be for the automation aspects and the management aspects for the 5G services.
I mean, network slicing has been defined, for example, at NGMN. We saw some presentation of 5G MF, also with a specific definition of network slicing. There are efforts in 3GPP to bring these high-level definitions of slicing into standards, which will be, yet again, more defined into the different RAN, SA working groups. So I think the definition of slicing, it's moving clearly towards a fluffy term to a very well-defined term where interoperability will be fixed.
No more. Okay.
I'll just quickly mention, there's in the ETSI ISG for NFV, there's a recently produced document where it's slicing as a use case, and it's really the end-to-end service chaining, which can comprise physical and virtualized network functions. So I suppose I'm just saying that to sort of point out, it looks as though there's definitions appearing in different places depending on what the context is.
So I have another question on slicing. What do the panelists think about the slicing of the radio access network? I mean, most of the questions here, for me, they were more targeted to the core network, to functionalities in the core network. How much do you think the slicing concept can be applied to the radio access network, and where are the limits?
I mean, if you saw my presentation at the end, I mentioned slicing at the RAN side already happen in terms of resources with network sharing. So there are already products that you can buy which do network sharing, where you can have variable, dynamically changing share of resources per tenant. That's already available. You can do VPNs up to the mobile core, where you have isolation between them. And what is missing here is the NFV part, mainly, and the connection to SDN if you want to have a unified framework based on ONF or something else. So the NFV part is something that, from what I have seen, is not happening yet, but it's on the works in many different projects, especially in the space of mobile edge computing, as we have seen in the presentation from Vasilis, where we are looking at the different use cases for network slicing, for verticals, and saying, okay, this one needs more processing at the edge, this one needs lower latency at the edge. And I think at NGMN, they are already talking about templates for network slices, so not allowing any network slice programmable at any level, but predefining a set of slices tailored for different verticals or use cases, as you want to name it, where you will have a clear implementation of what do you need to do in order to fulfill these requirements for slicing. But basically at the RAN side, at the front haul side, you can already do resource sharing, and the part that is missing is the network function virtualization part for these more verticals use cases.
No more opinions on radio stuff. Good. Can you? So.
Thank you. So my question is not about slicing, but it's...
Thank you.
But it's strongly correlated to slicing, but not only. My question is about SLA. Everybody is talking about SLA. So, and I'm not sure that we have well defined what a network service is and what are the attributes of this service. Everybody is talking about jitter, delay, and maybe throughputs, but there are many things that can also describe or, I mean, be useful in order to coordinate with other services like computing and so on. And we don't have anything about internal standards as of today. So my question is, do you think we need this? And in case you think you need this, where is this standards to be? Is it TMF? Is it IETF? Is it where it is? I mean, and just to be a little bit more precise, I'm also thinking about security, the level of security, the level of reliability, and so on, not only jitter and the classical KPIs.
Well, that's a hard question to answer because security is so I mean, spanning so many things that it's hard to say where should be standardized because depending on the scope, the security implications are much different and the security issues are much different. So I think we need to tackle security and isolation in all the levels or all the stacks or all the functions of the network. Of course, if we are talking about security in the terms of networking security or security in the terms of pure networking aspects, that's ITF kind of thing could be the place. But if we're talking about security, for example, or isolation in the terms of ensuring that a tenant cannot access to the data of another tenant, that I guess is also part of the EuCNCV architecture thing. They are looking into these aspects. I don't know where then the work will be done because EuCNCV is only basically proposing the stuff that should be done but not really doing all the, right? Kind of. Well, you can then correct me, but then we need that kind of work be done. And I think that's very important, this kind of isolation, as I mentioned, in terms of ensuring that in an EuCNCV architecture, one tenant is not really capable of getting access to the other tenant. And I guess that will, unless it's properly fixed, it will slow the adoption at the end, because that's a risk that you cannot really accept.
I will take the prerogative of being the convener of the panel to try to address this as well. On the one hand, when we're dealing with, I would say, not standard or not traditional KPIs, going beyond that, this is something I see very much connected with all the ideas that we are elaborating right now about intent and how you declare what you want from the network, that not necessarily belongs to the traditional model of the network. This is a tough question. It's a very interesting question that has much to do to have a clear model of the network that we still don't have. We keep talking about topologies, and even when you're talking about topologies, people are talking about different things. Unifying this is something that we have to do, and I fully agree that we have to do. And the model that I would like to follow for that is precisely of a shared resource, and that sharing the resource, what you had to do is to first assign a fair share to anyone that is asking you according to their privileges or the money they're paying for it, because it's the way in which we, in a open economy, you measure what you are asking for, on the one hand, and the rest of requests that you have from the other users and the management policy that you're applying. You have to declare how to keep a certain stability, a certain set of properties that you cannot afford to lose. All this is very much connected, in my view, precisely with the same scheduling problems that you have in an operating system. It's sort of, you have competing processes asking for a set of resources that you have to organize, and that requires, and this is something that I'm not sure it was Carlos or Paul, the one who was mentioning precisely this analogy with the development of an operating system, in which is very important, which is not, and this is something that in my view is important, is that there's nothing to do, or well, there's less to do with the cloud environment. In general, the networking people is obsessed with clouds. We want to be like the cloud. Probably we should start by trying to be like one computer and then go to the cloud. But this is a personal statement. So yes, it's true that this is a challenge. And just a note of what Carlos said, there was inside the EuCNCV, there has been some discussions about what to do precisely when you see when we see a wide gap that is not likely to be filled by other standards organization, because originally we were committed to tell the others, hey, do this, please do that. probably in some cases we will have to do ourselves, because otherwise the momentum of the proposals around NFV could be lost. And this is something that we still is under discussion, but I would say that the commitment and some signs in the recently created working group that is called SOL for solutions is precisely addressing.
A big problem I see here, based on your question, is if I take your question as who will provide the SLAs coming from the verticals, where is this defined? Because the ones from the, let's say, MVNOs and telecoms, we can take, we have the channels there, right? And I will ask the question here, who will be considered here as a representative of an industry vertical? Can you show your hand? You? So we have one.
Well, we have a kind of vertical as well.
So I think this is really the problem. In our telecom environment, we are coming more bottom-up, trying to figure out what the verticals are interested on. And probably I think all of us are trying to get in contact with verticals and get their requirements, but we don't have yet, I don't know if we will ever have a clear channel to actually get these requirements into our specifications at CNFV 3GPP, because all of us are doing this mainly indirectly. We have one-to-one talks with different players, and then going into the standards and saying, this is our impression of what automotive or e-health or education or energy want to have, based on a one-to-one discussion between one company, one vertical, which it's of course not representing all potential players. So I don't have a good answer to that, but I think this room is representing the problem that we have in terms of the representativity of verticals in our telecom space.
Four minutes left. Domenico.
Hello. So the question is maybe starting from the last speaker was saying there are these open source initiatives and there should be more cooperation with the standards. My feeling is that open source communities are going very fast. Standards go very slow. And some time depends on what is basically the field. So is there a different time scale there, and you think this is really possible that standard bodies can influence and can drive the adoption of open source standards in this?
So I fully agree on that there are different time scales. The reasons for that, I guess that another discussion, but they are at least the standardization bodies that I know are very much slower than the open source projects. And I think that they are aware of that, and they see also the...
I disagree. But
that's good to disagree, but I mean... so then I see in those standardization, and at least I'm talking about ITF, that they see that, and they are trying to change that, because they see that the open source project may end up being the ones doing the de facto standards at the end. So I think that they have to change, they have to cooperate, and they will mutually benefit from that, because standards have products already supporting the functionalities. The chances that those get into the market are much higher. And also, if open source communities are doing things under the coordination or at least synchronization with the standards, the chances that those are interoperable and are usable are also higher. So I think they should benefit, and I strongly believe that the timelines are not that equal or not that similar.
Now, if I can explain myself. I disagree because, it's true that the perception is that open source goes much faster than standards. But they do that for one fundamental reason, is that in open source you can do whatever you want. In a standard you have to convince 100 people that you are proposing is right. In open source you say, this is my project, take it. If you don't like it, take another one, make another project. And this is, that's, the comparison is not fair, first. Second, standards are supposed to be very slow because since you start, just to take the example of the ITF, since you start with the first draft till you have the RFC, can pass 3 years in average. In open source, you make a pure crap of code that does nothing but compiling and say, hello world. You say, hey, I have a project. Here it is. It's an open source project. I mean, it's much easier to say, I have something in open source. So at the end, when it comes to producing something that can be used as a real reference implementation, I doubt that the times are much shorter. I mean, probably in some cases, when things are very clear, when you have a very clear goal, in the case of a seed project, the original OpenStack, for example, not the current OpenStack, the original OpenStack, they were 4, 5, 10 people very focused, going for delivering something, fine. They were much faster than if you would have gone to a committee to make a decision. Right now, my impression is that most of the big projects in which there are many interests and many pulling and pushing forces in different directions, things are not that faster. With the exceptions of naming things, or saying this is a feature when it's not exactly a feature, but it's a module that does something that is close to what you want, but not exactly doing, and that you cannot rely on to provide a reference implementation. So, maybe you. And as a summary, open source is a different way of doing standards. Instead of writing a document, you're writing a reference implementation. But the time that takes having a reference implementation that can be used as a real reference implementation and not as a wannabe reference implementation is comparable because at the end, you have humans doing things and you have humans with different interests and different beliefs and so.
In my sense, I think the two open source projects and standardization bodies have really distinct roles. And open source projects can really help providing some kind of blueprints to the bodies, the standard bodies, thus accelerating the process, I would say. But they have a different scope. So this is my point.
Okay, but with this, are we allowed? Panagiotis, Luis? 5 minutes, okay. Oh.
Sorry, just to complete the question, and I agree with Diego, you should think also of how many time it takes to disappear. In terms of feature, if you take the comparable granularity of featuring between standards and open source, how long does it take for a feature in an open source to disappear, replaced by something else? So instead of stability, it's not the same.
At the end, it's a matter of perception. If the community is perceiving that they are much faster, well, if we all believe that they are much faster, in practice they are much faster. But then it's when you have to measure it with the rate of real adoption and the real contribution to the industry. That is something that where I have my doubts in the spite of all the marketing fuss around this kind of initiatives. Okay, any final comments, even in favor of the fast pace of open source projects?
Well, I have two comments actually. One of them is regarding the security aspects of SDN and NFV. I believe it's a good opportunity to benefit from the ecosystem of the overall telecommunication industry, this security aspect. You said that we need to do our own precaution, our own measurements or our own measures. But I believe that it is much better to utilize already existing products and their functionalities to integrate our SDN and NFV environment. I believe that with a good synergy, we can have much better and much faster product level functionalities in our systems by utilizing this ecosystem. I believe you meant that as well. That's another aspect of your words saying that. Another issue that was for the security, the second issue regarding the security again, since it is software, I mean, in the controller level, if it is not in the deep technological expertise level, since it is in software, we can, program our systems as much smart as we are, and we can get appropriate precautions immediately with respect to the coming threats. So I believe SDN and FE, in that perspective, provide a very good infrastructure for security purposes. The second portion of my comment would be regarding this open source and standards activization. One aspect we skipped of the open source benefits is that it enables small companies, small startups to contribute to the process. So this is a very important that we should not, I believe, skip, or we should not take apart from the benefits of the open source. Thank you.
Just as a closing comment, I frankly wish that this opportunity for small companies would became true. It's something that from time to time I have my doubts, because looking at the behavior in the big open source projects, at the end ended being controlled by the big corporations. It's a matter of resources. I mean, at the end, if you go to whatever the place, at the end, if you have more people, you can apply a stronger pressure, bring more developers. It's difficult unless you have a good idea. And this is something that I'm not going to contend that someone with a very good idea can come, etc. Though I have my doubts about the recent business models of many startups. But this is something that is for another.
Just as an example, I mean, I don't know if it will be part of advertisement, but as Argela right now, we are having the chance of having a demo together with AT&T in South Korea. So without such an orchestration or such an organization, I believe it would never be possible to go with AT&T and Argela, a Turkish company. So,
well, no, I mean, if you think that you have enjoyed personally in your company an example of this, happy. I mean, I'm more than happy that there is the opportunity. As a general rule, I have my doubts that this is something that is probably because I'm getting older and more skeptic, and that's simply. When you said about security, again, this is, I mean, the problem with security is that we have shown so many cases that even being very careful, security is the most delicate issue, because a very, very small mistake propagates like an atomic explosion. This is something that the chain reactions are extremely dangerous there, and we have to be extremely careful. But for sure, we should learn from what came before us. We have spent the last 5 minutes that were granted to us by the people coming after us for the closing session. So thank you to our speakers. Thank you to you all for your interaction.